for this meeting. Right. So about our speaker. All right. So this evening we have the privilege of learning from Dr. Braimoh Bello. He's the technical lead at the Center for Statistical Analysis and Research, and he's an honorary lecturer at the University of Witwatersrand, South Africa, where he has been teaching for over a decade. Dr. Bello obtained an honors degree and a master's degree in medical microbiology in Uniben, and it was followed by a Master of Science in Medicine, studied epidemiology and biostatistics from the University of the Witwatersrand, before proceeding to Utrecht University in the Netherlands for his PhD studies in epidemiology and biostatistics. I need us to start using our emojis. I need us to, light the place up. So he has over 15 years of experience in research and more than 70 publications to his name. His work spans epidemiology, biostatistics, and program evaluation. Focus of his research, HIV/AIDS, occupational health, and most recently, COVID-19 transmission studies. Beyond academic contributions, Dr. Bello has been recognized by the Mail and Guardian as one of the top 200 young South Africans. He is also the author of Beyond Tomorrow, Fundamental Principles for Achieving Academic Excellence. And this is a testament to his commitment not only to research, but to, nurturing the next generation of scholars, of leaders. Dr. Bello brings a wealth of practical experience to his work. He consults with international organizations like the Global Fund. This evening, Dr. Bello will guide us through fundamental concepts in epidemiology. Specifically, we're going to be learning measures of disease frequency and measures of association. These are like the building blocks of how we get to understand disease patterns in population, how we assess risk factors, and how we make evidence-based decision in public health and medical practice in general. So please use your emojis, use the confetti. Let's welcome Dr. Braimoh Bello. Dr. Braimoh, you have the floor.
All right, Chidinma, thank you for a very kind and long introduction. All right, good evening, everyone. I hope you can all hear me. Yes, all
Yes, we
right,
can.
lovely. I just have to ensure that my voice and enthusiasm doesn't go down with the sun. It's been a long day. Uh, yeah, it's been a long day. I'm happy to be here. I'm happy to share with you guys. Like Chidima has said, just we can, like Chidima has said, the measures of association and measures of frequency and measures of association are fundamental tools in public health, fundamental tools to people who do epidemiological research. So I actually didn't ask you, Chidinma, how long do we have for this session? Because I have two PowerPoints. One is for the first one, the measures of frequency, and the second one is for measures of effect. Let me know how much I have so I can pace myself.
Um, okay, sir, we're very fine with you going for as long as you want. We are happy, but 2 hours is a good time.
Uh, okay,
But we can
let's
go more than
see. Let's
that. There's no
hope.
limit, sir. You can, yeah.
Yeah, maybe we can do an hour each. The maximum, maybe we can do a maximum of 2 hours. Let's see how it goes. All right, we'll take the first hour. We can break for 5 minutes and then come back and take the second lecture. Okay, so do I have the permission to share? I see that I do have, and I'm starting with the measures of association, measures of frequency, I beg your pardon, measures of frequency. All right, there are four things I would like every participant here to go home with at the end of today's session. The first one is to understand the common types of research questions, and the second is to understand the different measures of frequency, what a measure of frequency is, and to be able to define the common measures of frequency, and also be able to calculate and interpret the common ones. All right, it was Lord Kelvin who said once, yeah, you probably know Lord Kelvin, all of you who did chemistry or physics, we have degrees Celsius and we have the Kelvin scale, the Kelvin scale. It says when he said that once knowledge of science, I'm paraphrasing, once knowledge of science begins when he can measure what he's speaking about and express it in numbers. So you are not a scientist, he was saying, or he said, if you cannot measure what you're speaking about and express it in numbers. To the ordinary person in the street, effect is an English word, but to the epidemiologist or someone in public health, effect is a number. To the man in the street, impact is an English word, but to the man in epidemiology, impact is a number. So our knowledge of science is really premised on our ability to measure what we're talking about, the concepts we are facing or we're faced with, and express that concept in numbers. I agree that to a very large extent, this quote is correct. I thought I should take a step back and ask everyone, or at least revise what a research question is. Because we cannot talk about a measure of frequency or the measures of frequency if we do not understand what a research question is. If I had enough time, if I was running a workshop, I would probably ask you guys some questions, and maybe I would. Maybe I still would. I still will. Uh, maybe I will ask a few questions and ask you to put your answers in the chat box. But one trick question I like to ask people is, do men cheat more than women? And then when I ask that question, you can hear different opinions, some of them very emotive and based on people's perspectives and experiences. Oh, I think men cheat more than women. Oh, I think women cheat more. We just don't catch them often. And then I eventually say to them, it's really a trick question. That's not the kind of question we can answer in research. Unless, of course, we refine that question, we cannot answer it as a research question. A question like that is good for social discussion, no, beer parlor discussion, social media discussion. But when it comes to research, we have to refine it and we have to make sure it's clear. I think it's already concise though, but we have to add clarity to it and make it more focused. For example, what do you mean by cheating? In research, we'll have to define what cheating is as a verb. Uh, is it emotional cheating, financial, sexual? What is cheating? And we can then go on to say, which men are we talking about? The men of the 1950s, the men in the 1950s, or the men today? Educated men or uneducated men? The man in Lagos or the man in Johannesburg? We start talking about population, place, and time, people, place, and time. So it's very important for us to start with a very clear research question when we want to talk about, when we think about the concepts such as measures of frequency and measures of effect or measures of association. Well, without spending a lot of time on that, a research question is a clear, focused, concise question which a researcher seeks to answer. I think I should have shown my face at the start. What do you think, Chidinma? uh, it does help people to see the lecturer talking.
Yes, sir, you can. Would be glad to see your face. Yes, you can show your face.
Let's do
Absolutely.
that. Let's do that. Let's make it a chilled evening. Let's not make it too serious. You can see my tired face. All right. So a research question is a clear, focused, and concise question which a researcher seeks to answer. It is a reason and focus for the research you're doing. Can you see my face, by the way?
Yes, sir, we can. We can see
Lovely,
you.
lovely. Okay. Now, this is what is important, guys. This is what is important. As a consultant, it's important for me to know fundamentally that there are three common types of research questions in the universe. This list is by no means exhaustive. There are many other types of research questions, but these three common types will probably account for 80, 90% of the research studies out there. That's important to me as a consultant because when I sit with a client and the client is briefing me what they want to do, my brain already begins to think whether they are looking at a frequency project, an association project, or a trends question. Sometimes a project could have all three. Usually, a project would have two of them. And sometimes a project would have only one, a frequency question, for example. So you can already see why it's important for me to tell you the different types of research questions. Because my assignment tonight is to talk about the measures of frequency and the measures of association. And those two are the common types of research questions. So let's talk about the first one, frequency question. A frequency question, we will call it a descriptive question in, is a kind of question that seeks to estimate how common a health event outcome is in a population. It seeks to estimate how common an event or an outcome is in a particular population. That's a frequency research question. So you come across things like prevalence studies, incidence studies, knowledge, attitude, and practice, CAPT studies. These are all studies that seek to estimate how common a particular outcome or an event is. I will repeat myself occasionally because I believe in emphasis by repetition. And I think such emphasis is important for making the point and for people understanding. A simple example is, let's assume one of you here, you choose a research project and your research question is, what is the HIV prevalence among antenatal care attendees in Rwanda in 2019? Or let's say 2026. If you cannot relate to Rwanda, I already have Lagos State in the second one. You could say Lagos 2026, since I'm saying one of you. Let's say 2026 in Lagos State. What is the HIV prevalence among antenatal care attendees in Lagos State in 2026? So what you're trying to do with such a study is to say, among these people We have a defined population, and it's stated there. Antenatal care attendees, maybe by attendees, we mean public health facilities. Attendees of public health facilities. So we have a very defined population. We have time, 2026 or 2019. And so what's the prevalence? And of course, I'm here to talk about prevalence, and I'm using prevalence in my research question. But anyway, we'll get there very soon. That is an example of a frequency question. Now, if prevalence is too technical, let's take the second question. Let's look at the second question. What percentage of clinics in Lagos State provide PMTCT services? Maybe PMTCT, we're talking about HIV or syphilis. Or for those who are not medical, I can give another example. Don't worry. PMTCT would be services provided to pregnant women to prevent the transmission of infections from the mother, the pregnant mother, to the unborn child. Uh, one common infection under such a program would be HIV. You know, what percentage of the clinics in Lagos provide these services? That's the question. I guess that's clear. Now, let us look at a study we did for the South African government last year, and we were commissioned to the government of South Africa said, here are 22 dysfunctional districts. I think we call districts local governments in Nigeria. And I like to think that not everyone here is from Nigeria. So if I use Nigeria as an example, do pardon me. It's because I would imagine most people are from Nigeria, and it's the most populous country on the continent, most populous Black country. So let's stick to Nigeria for the most part. We'll call district local government in Nigeria. So the government said to us, Caesar, there are 22 dysfunctional districts in South Africa. They are called dysfunctional because of A, B, C, and D. Essentially, they are not providing the services they should be providing. We want you to go into those districts, conduct a study, and estimate for us the frequency of A, B, C, and D. And of course, it wasn't just A, B, C, and D. There were about 50 outcomes. The percentage of people who are employed, the percentage of households with electricity, the percentage of households with water in their yard, outside of their yard, the percentage of households with sanitation services provided by the government, and this and percentage of this and that and that and that and so on and so forth. That's a frequency study. Any of my researchers could easily do that. They just need to estimate percentage, percentage, percentage. You go back and say to the government, amongst these 22 dysfunctional districts, the percentage of people who are employed is this amount. It's as simple as that. You've answered the question. So the first thing we're taking home today is that frequency research questions need measures of frequency. If you have a frequency research question, you need a measure of frequency to report your findings in that research. But when we talk about measures of frequency, we really mean in public health, 2 or 3 common things. Okay, and we'll get there very soon, but I'm still talking about types of research question. The next type of research question is association question. Association question seeks to determine whether the occurrence of one variable affects the occurrence of another or depends on the occurrence of another. Affect and depend is the same thing, it's just in 2 different directions. So association questions are research questions that focus on relationships between variables. For example, I'm going to use the first example I just gave, and I'll come back to what is on this slide. Unemployment among these 22 districts, the percentage of people who are unemployed in this 22 districts was 70%. for example, 70%. And the government could say, okay, Braimoh, we know we asked you to do a frequency project, but please, can we throw in some association questions? Would you be able to do that for us? All right, we'll do that. And this is exactly what happens. This is exactly what often happens to consultants. Can you help us check if unemployment is associated with race? Can you determine whether there is an association between gender and unemployment? In other words, if we partition unemployment by gender, would we see that it's higher in one group compared to another? That's association. We're essentially trying to determine whether gender has some kind of influence, some kind of relationship with unemployment. So that kind of a question is an association question. And people who engage in association questions will need to report measures of association. So you have some examples on my slide. I'll take the first one. Is there an association between circumcision and HIV infection? And the second question says, is income level dependent on educational qualification in Nigeria? Just, uh, just for the sake of it, I'd like to see your answer to the second question. Everybody, give me your thoughts in the chat. Yeah, yeah. This is all right. It's okay. I've seen, I think if the first if the first 20 submissions are representative, maybe they're not representative actually. The first ones came with a lot of no's, and now I'm seeing a couple of years at in the tail. Okay. All right, no problem. We can continue. We can continue. I would like to think, I would like to think that in almost every country of the world, income level is dependent on educational qualification. And this is where if I was running a workshop, I would have more time to explain. Uh, let's see how it goes. But let me explain to you quick. I don't want to go into statistics. We're taking epidemiology today, but many of your answers in the chat is almost wanting me to go to statistics. But let me say to you that almost every country, income level will be dependent on educational qualification. Now, the reason many people say no is because they know of people like Bill Gates who who dropped out of university and is a billionaire. And maybe they know a few politicians in their communities who didn't go to school and they're very rich. But when you start to deal with statistics, you would know that when we say dependent, the word dependent is not at an individual level, it's at a group level. Okay, it's at a group level. So when we say income is dependent on educational qualification, we are saying, well, of course, we know you know some people who have PhDs and they cannot eat. We know that. You also know some people who didn't go to school and they're very rich. We know that. But often, what many people don't realize is that those are the exceptions. Those are the exceptions. If you take the top 20 richest people in the world, I'll bet you that 18 of them have a degree or a master's degree. About 10 of them have master's degrees, and 18 out of the 20 all have degrees, or at least 15 out of the 20 all have degrees. So when we say income level is dependent on educational qualification, we're saying, look at everyone who has no education and compare them to everyone in the country who has secondary education. And then compare those to everyone in the country that has tertiary education. On average, if we took an average of each of these three categories, there will be dose response. As education increases, so will income level. That much I can bet you. But anyway, I'm not here to answer the question. I'm just here to tell you. The data will answer the question. It may not be the same in every community. It may not be the same in every workplace, but at the level of a country, it's almost it's almost always going to be that income level is dependent on educational qualification. Like I said, I'm not here to answer this question. I pretend I don't have the data. I'm just using these two questions as examples of association questions. And then the third one, which I would not be spending time on, is an interesting one. Okay, Stephen, I'll give you an opportunity after this slide. That's a good time to ask a question. The third one, the third type of research question is what we call trends questions. Trends questions are time series questions that seek to determine whether the frequency of an outcome has changed over time. Whether the frequency of an outcome has changed over time. I will not dwell a lot on this. I rather want to focus on the first two. Let's take the first question from Stephen. Can you use your microphone, Stephen? You had your hand up. Was that a mistake?
Let me unmute him. They're all muted. Everyone
Okay.
is muted. So let me search for his name and unmute him.
Oh. If we can trust everyone to be disciplined, maybe
No,
they
sir, we
can.
can't.
Yeah. Yeah, I know. 100 people is it's a big number.
Yeah, and there are more actually. Some persons were not able to join. The group is full. Okay, Stephen, I've asked you to unmute.
Good evening, everyone. Sorry, it's a mistake. My network here is very poor.
Okay, thank you.
Okay.
It's okay.
No problem. Yeah.
Please, for the rest of us, if we have any questions, I'd appreciate that we keep them till it's time for us to take questions. So let's just listen and not break the flow. There's no problem. We can go ahead.
Thank you. And now I want to ask questions. Everyone, put in the chat box the research question you are thinking about for your MPH program. Maybe you're still conceptualizing it. Maybe you started collecting data on it. Can you put the research question in the chat box and tell us whether your research question is predominantly a frequency question, an association question, or a trends question? Please put all of them in one line. Don't break your submissions. Otherwise, we will not be able to link them. For example, I'll say my research question is there an association between circumcision and HIV? I believe this is an association question. All right, I will give everyone a minute or two to make their submissions.
I don't know if we're going to get answers yet. Um, okay,
We have
you
the first
can.
one from Khadija.
Okay.
Is there an association between Hamilton and the prevalence of burns in urban area? That's a good one. So that's clearly an association question, Khadija. There's an association between health-seeking behavior and cultural beliefs. And Gina says that's an association question. I agree. Khadija, your question is great. It's okay, but I'll probably just say, bonds without adding prevalence, but it can still stand. And then we have from Salome, I'm considering an association between postpartum care and postpartum depression. Everyone is interested in association. I haven't seen a frequency question so far. The relationship between uptake of family planning and education in Nigeria. Amazing. That's a user. Does it have a name? That's another association question. Okay, maybe we can stop. Everyone's question is an association question. Is there an association between poverty and fertility? And is there an association between poverty and fertility? That's Chidi. Uh, and then we have a Zoom user who said, is there an association between physical activity and obesity among university students in Abuja? All right, more and more coming. I cannot read all of them. Afilemon says, I'm considering a relationship between sickle cell disease and delay wound healing. Interesting. Interesting. Go for it. Uh, and of course, many of these things are already documented in textbooks and literature, but you can always try to find a small, interesting group, among young women in Plateau State or among students here and there. Okay, I really feel that's okay, guys. Thank you. Thank you. We can stop. Let's continue. I really feel that I should probably show a bit of statistics, but I think I'll do that later. Let's continue, guys. No more submissions, so you can focus. Now that I have shown to you that there are frequency research questions, and nobody here has submitted a frequency research question. If they have, then, oh, okay, I've seen a Zoom user who said, what is the prevalence of hypertension among adults aged 30 to 60 years in Sokoto State? Yeah, that's the first frequency question I have seen. If I've missed the others, pardon me, but it's not a train smash. Most people don't want to do frequency questions. Why? Because they think it's not scientific enough. It's not interesting enough. And I agree with them. Although research frequency questions can help us to solve a lot of problems, like what is the prevalence of hypertension? How common is hypertension in this group? It's an interesting question. Please stop submitting. It's an important question that we need to know, that we need to answer. So it's interesting, it's important, but the majority of postgraduate students would want an association question. And majority of postgraduate schools will encourage their postgraduate students to develop association questions. Now, do you know what is interesting about association questions? Maybe you already got it when I was talking about the project we did for the government last year. You cannot do or you cannot answer an association question without first answering a frequency question. Now, I'm going to repeat that sentence, and I want you to put a yes in the chat box if you agree with me or if you understand the sentence. You cannot answer a frequency question without answering some association questions. Lovely. Okay, everyone agrees. Lovely. Okay, you can pause now. That's just a cross-section of the class. Lovely, thank you. So now, we all pass through frequencies, even trends. What is trends, really? Trends, for those who can catch this quickly, I'm not going to over-explain. A trend question is an association question where one of the variable is time. So instead of saying circumcision and HIV, that is an association, the person says the trends in circumcision over time. So one variable is circumcision and the other variable is time. As time is changing, do we find a change in circumcision or in the number of circumcisions? So trends is really just another association question where one of the variables is time. So trends question also requires that you pass through frequency. So if I ask you, what are the trends in circumcisions in your state, 2010 to 2020? You would first have to get the frequency of circumcision for each year before you even talk about trends. So let's focus on measures of disease frequency. In epidemiology, when we talk about measures of disease frequency, we're talking about a statistical quantity, a concept that is used to express the extent of morbidity, mortality, or other health events in a population. We also call them measures of occurrence. The measure of occurrence. One's knowledge of science begins when he can measure what he's talking about and express it in numbers. There are different measures of disease frequency, and the choice of the measure of disease frequency you use in your study will clearly depend on the study design and the inferences you want to draw from that study. Your study design will dictate for you the measure of disease frequency you should be using. Here are three common ones: prevalence, incidence, and mortality rates. If you leave the School of Public Health, you should be able to answer these three things, or at least the first or three actually, but majorly the common ones, most textbooks will stop at prevalence and incidence. But I thought it's important for me to throw in mortality. So when you leave School of Public Health, you should be able to explain these two concepts very easily. Prevalence is a proportion of people in the population affected by a particular disease at a given time. If you follow the language, it says the proportion of people in the population. Of. So proportion is from the word portion, isn't it? It's from the word portion. The portion of the population, a portion of. So because it's the portion of the population, then naturally, the population is the denominator. So if you look at the formula, the denominator is the number of people at risk in that population. That's the people in the population. The number of people at risk in that population. Number one, a population is the denominator. Number two, not everyone in the population goes into the denominator. It's those who are at risk. So if you're talking about a disease that affects only men, prostate cancer, your denominator will exclude women. If you're talking about a disease that affects only women, your denominator will exclude men. If you're talking about a disease that doesn't affect children, your denominator will exclude children. So it's the proportion of people in a particular population who are at risk of developing the disease that actually got the disease at a particular point in time. If you remember probability, the probability of an event is the number of desired events divided by the number of all possible events, total outcome, the universe. The number of desired events divided by the number of all possible outcomes. So if I had one black ball and two blue balls, I would have three balls in the universe. One black, two blue, three balls in the universe. The probability of picking a black ball is 1/3. And that probability is a proportion. It's 1/3, 0.3, or 0.33. This is why we say prevalence represents the probability of already having the disease. I'm going to come back later and tell you that prevalence is not a true probability, but if we're going to interpret it as probability, we are going to say it is the probability of already having the disease. I'll just get ahead of myself. Incidence is the probability of developing the disease, while prevalence is the probability of already having the disease. Because it's a probability, not technically, but kind of philosophically. We often express prevalence per 100. It's arbitrary. It's arbitrary. Could be per 1,000, but very often we use per 100. It's the same with incidence. So sometimes per 100 or per 1,000. But again, let's stay here. Let's not get ahead of ourselves. Anybody, do you want to use the microphone? Okay, we don't have time for that because there are many of us. I was going to say, I'm gonna get to a point where I ask you guys to use a microphone and answer some questions, but for the sake of time, I think I have 20 more minutes here. I was going to ask you to explain to me the meaning of this sentence. The prevalence of infertility amongst female laboratory staff in the South African chemical industry in 2007 was reported to be 14.3%. And then there is a confidence interval there. I'm not here to explain confidence intervals, but I'm here to say to you that the population is given, the time is given, and the percentage of that population that had that health outcome is given, and that's the prevalence. I know somebody will be saying, oh, can you just explain the confidence interval? That will be digressing. Let me finish what I came here to do. If there's more time, you can take me back. So here is homework for you, just for you to master it if you haven't already. You have to think through these things. You have to take your notes home and own these concepts. You have to think through them and talk to yourself, talk about them to yourself. For example, what is a proportion? Especially for those of you who didn't do mathematics. Why is prevalence a proportion? Why? Why is it a proportion? But the third one I haven't covered today, I want you to go home and distinguish between point prevalence, which is what we often talk about when we define prevalence, and period prevalence, which is often not the example given in textbooks. But it's important for you to know the difference between both. Here are factors that influence prevalence. Mathematically, it's very simple to conceptualize. Prevalence will increase if the numerator increases or /and the denominator decreases. So if the numerator is increasing, the quotient, whatever the answer you're getting, will be increasing as well, because the numerator is directly proportional to the answer. If the denominator decreases, it will also increase. And the converse is true for the other side. So let's look at this, the left-hand side, for example. What increases the prevalence of a disease? Or if the disease has longer durations in its history, if the natural history of the disease is a long one, then the prevalence will be high in society. I was going to ask you examples of disease with long duration, natural history with no intervention. You would think about HIV and hepatitis. You think about syphilis, hypertension, So diseases that stay long in the population or in people, we have high prevalence. And it's the same thing with if we can prolong life, even where there is no cure. An example is HIV. it will have a high prevalence. In diseases, when we have an increase in incidence, the incidence becomes the tap you open, and the prevalence becomes the drum or the bottle, or the tank where the water pours into. So when incidence increases, prevalence will increase. When cases are migrating in for whatever reason, in migration of cases, prevalence will increase. If healthy people are leaving, maybe they're going out to look for jobs, prevalence will increase. If there's new technology to improve diagnosis of that condition or reporting of that condition, prevalence will increase. And you can think about the other side. Let's talk about incidence now. If you look at incidence, we say the incidence of a disease is the number of new cases of a disease that occur during a specified period of time in a population at risk. Now, you see again here, a population at risk. But what you're seeing for the first time, at least what was not there for prevalence, is new cases. The number of new cases. Prevalence is existing cases or cases now at this point in time. All cases, prevalence, while incidence is new cases. Prevalence, of course, I'm going to differentiate between both of them very soon. Prevalence is at a specific point in time, mostly. Incidence is a specified period of time. And I think that makes a lot of sense. Now, incidence is expressed per 100 or per 1,000, or even per 10,000. But what's critical here is that when we talk about incident cases, we're talking about new cases. When we talk about prevalent cases, we're talking about the cases that already exist or existed, the cases we met, already existing cases. So while prevalence is the probability of already having the disease, incidence is the probability of developing the disease. For example, if the prevalence of diarrhea in this class is 100%, then the probability that you already have the disease is 100. But incidence is different. Because in incidence, we are talking about new cases. Just a second. All right, the stars represent the disease cases. No, the star is a good thing. The star represents the healthy people, and the question mark represents the disease cases. And this is February 2026. And the disease we're talking about is common cold. Common cold. So let's assume that there are 1, 2, 3, 1, 2, 3, 4, 5, 8. Let's assume there are 8 people in this population. All of them are at risk of common cold. I think every human being is at risk of common cold. And we say we want to do a prevalence study and an incidence study. We want to undertake a project that measures the prevalence and the incidence of common cold. We make that decision in January, and we start the project. We start data collection in February. Again, you don't have a microphone, it's okay. I was going to ask you, what can we measure immediately? What we can measure immediately is prevalence. Prevalence as of February 2026 is equal to 3 divided by 8. As of February 2026, the prevalence is 3 divided by 8. 3 people have the condition of 8 people who are at risk at this particular point in time. We could assess all of them in 1 month. That's okay. Sometimes assessing them may take you 2 months, 3 months. It doesn't matter. But we assessed all 8 people. We checked them. We tested them. Of the 8, 3 of them had common code. Prevalence is 3/8. How about incidence? Sorry, you cannot measure incidence in February. You have to wait because incidence is not at a point in time. Incidence is over a specific period of time. Specific period of time. Incidence is not at a point in time. It's over a specific period of time. Why? Because we are looking for new cases. These 3 people are no longer new cases. They are no longer at risk. So they cannot be part of our denominator. We met them already infected, and therefore we need to create a new population at risk. And we have to say, these 5 people are the people who are at risk. The 5 people are the people who are at risk. For you to be at risk in incidence studies, you have to be disease-free. If you already have the disease, you're no longer at risk. So we have 5 people who are at risk. We will follow them through over a period of time because it's common code. That period doesn't have to be very long. It could be 6 months or 3 months. We'll choose 6 months. If it were lung cancer, we would say 40 years or 20 years. But it's just common code, 6 months. And then after 6 months, we come back and say how many people got the disease. And we say 2 people got the disease of the 5. And now we can calculate incidence. Incidence becomes equal to 2 out of 5. Of the 5 healthy people, we got 2 new cases. Please give me a yes in the chat box if you understand what I've just explained. And give me a no if you have a question. All right, if you have a question, please drop it in the chat box. And Chinema, if I miss the question, please call my attention to it. Now, that's the fundamental concept of incidence, new cases. I have 10 more minutes. But I should now extend that concept and tell you there are 2 kinds of incidence measure. You only got it today. Oh, I'm glad. If there's one person who got something today, that's good. Thank you, Damaris. There are 2 kinds of incidence measures. One is cumulative incidence, and the second one is incidence rate. It's really an incidence density, but commonly called incidence rate. So there are 2 kinds. If you get that incidence that I just explained to you, that's enough for you in public health. But if you're an epidemiologist, you need to proceed and understand that there are 2 types of incidence. One is cumulative incidence, which is what I have just explained. And 2 is incidence density, which I'm probably going to spend more time on now. The difference, first of all, both of them we look at new cases. Out of those 5, remember my 5 people who did not have the disease. We followed them up and we got 2 people who had the disease. So whether you are talking about cumulative incidence, CMI, or incidence rate, IR, they both are looking at new cases. However, they differ in the way they conceptualize the denominator. Cumulative incidence is the formula, is what I just explained. Cumulative incidence is the proportion of disease-free people at risk who develop the disease during a specified period of time. If you're not using period of time, you are not defining incidence. You're probably defining prevalence. If you're using it at a particular point in time, you are defining prevalence. If you're using an interval or a period of time, you are defining incidence. So what I've just explained is that in the explanation I just gave to you, I just showed to you that there were 5 people at risk at the beginning of the study period. And out of those 5 people, we saw that 2 became positive during that period. That is called cumulative incidence or incidence proportion. It has almost the same mathematical formula as prevalence. Both of them are proportions. If I gave you my data set right now, take this home, listen to this and take it home. If I gave you my data set right now of common cold, this is what a data set looks like, right? This is what a data set looks like. Think about Excel. Think about Excel, okay? And that's the first person, that's the first row, second row, third row, whatever. And I have here healthy, healthy, healthy. And I have here disease, disease. And I say to you, give me the percentage of people who are diseased. If you're using Excel or Stata or R or SPSS, say 2 or a calculator for that matter. So, Braimoh is 2/5. Okay, what is that? 40%? 40%. Okay. All statistical packages, boom, one command. 40% have the disease. Is it prevalence or is it incidence? The software cannot tell you because the formula for prevalence and the formula for incidence, for cumulative incidence, are the same. It's number of cases divided by population at risk. You need to read about that data set. That is why nobody jumps into data analysis without having some background information on the study. You need to read about the data set. If the data set says 5 people were tested in the community and 2 of them were found to have common cold, that's prevalence. But if the data says 5 people were followed up over a period of 6 months and 2 of them developed common cold during that period, that's incidence. That's cumulative incidence. So take home, the formula for cumulative incidence and the formula for prevalence are very similar. Statistically, the software is 2/5. But there's a problem with cumulative incidence. Cumulative incidence, let me tell you the problem with cumulative incidence and then we'll wrap it up. The problem with cumulative incidence is like a man, for those who are not in health, can I use another example? It's like a man who has 100 taxis. 100 taxis. 100 cars. Let's keep it simple, cars. People might wonder if I'm talking about taxation. 100 cars. Right? Trying to add an S to my cars. 100 cars. And the man is trying to calculate accident rates of these cars. Let's assume they're all Toyota Corolla, the same brand. It's trying to calculate the accident rates. No, let's use taxes. I think taxes is a better example. I go back to my taxes example. So a man has 100 taxis because we know taxi drivers, they are often very bad drivers. And he wants to calculate the accident rate of the taxis, of these taxis. And he gets to the end, says, I'm doing a cohort study, and I'm going to follow these 100 taxis for 1 year, starting January. And I get to the end, I check how many of them had accidents. So 20 of them had accidents. And the man says, oh, the accident rate is 20 out of 100, right? So it's 20%. And then he goes to report the taxis in our city, there are lots of accidents, involving taxis in our city. And then the taxi association says, no, you're an epidemiologist, but I respect you. You're an epidemiologist. I'm just a taxi driver. But I think your calculation is wrong because you came to the taxi, you came to the taxi park in January, you counted 100 taxis, but in February, we already had 15 taxis that developed mechanical faults and they stopped working in January. We already, have 15 taxis that developed faults and they were not working throughout. And that's January. Let's put that there, January. And in February, by February, we lost another 30 taxis. We lost another 30 taxis, another 30 taxis because the owners went overseas. They stopped working. They went overseas. So your 20% is not correct. I just thought I should improve whatever you're doing. And the epidemiologist says, thank you so much. So it's actually higher than I thought. So not all the 100 taxis drove or were on the road for 1 full year. And when you say 20 out of 100, you are not exactly correct. So what if we could devise another measure of incidence that is not cumulative, that doesn't cumulate everyone into 100, but rather says, I will use a denominator that accounts for how long you were on the road. What is the meaning of on the road? How long you were at risk. Because cumulative incidence assumes that everybody was on the road for 1 year, but in actual fact, some were lost to follow up, some died, some were lost to immigration, and so on and so forth. That is the concept of incidence rate. And mathematically, what we then do is to say, we are not going to divide by 100. We are going to calculate the total number of time these vehicles were on the road, the total number of time these people were at risk of having an accident. If you are no longer on the road because you already had an accident or because you traveled, you're no longer at risk of having an accident. Somebody who is already sick cannot be at risk of falling sick. Somebody who traveled to England and we don't know if he fell sick over there, we cannot assume we have followed him up for 1 year. That would be wrong. So therefore, let's devise a new concept. And that concept is called present time. Present time. We still use the total number of new cases, but this time we are using the sum of the length of time each person was at risk as our denominator. The total number of present time of follow-up. I will show it to you on the next slide. So maybe I shouldn't try to explain it here. If we had 100 people, we followed them up for 1 year. Each person was followed up for 1 full year. We didn't lose any of them. That would be the dream of every researcher, but it never happens like that. We followed it through this 100 people for 1 year. In total, we accumulated 100 person years. So our denominator will be 100 person years. Our incidence rate will be 20 per 100 person years. In other words, if you follow 100 people up for 1 year, 20 of them will have common cold. Well, life is not always that perfect. Scenario number 2, we could only follow them up for 6 months because we lost funding. We no longer have the money to follow them up for 1 year. If you follow 100 people up for 6 months, that's 100 times 6, 600 months, 600 person month. 600 divided by 12, because 12 months is equal to 1 year. 600 months, or person months, is equal to 50 person years. Scenario number 3, Trump came in and took all of the funding away. We only followed these people up for 1 month. Let's still publish something. Let's see what we found. 100 people followed up for 1 month is 100 person month. 100 divided by 12 is 8.3 person years. And then I have another scenario there. I want you to put the answer of the third scenario, of the last scenario, in the chat box. We don't have the time. I need to stop now. Here are the similarities between prevalence and incidence. Both of them are measures of occurrence. Both of them are use population with risk, especially cumulative incidence. And both of them are proportions, cumulative incidence. Prevalence affects incidence, can affect, can. And incidence affects prevalence, clearly. Yes, Chidima, I see your hand is raised. Just a minute, I'm wrapping up. How does prevalence affect incidence, guys? I want to use let me use a better example. If a lot of people have common cold where you live, that is a high prevalence area. It will soon affect you. So high prevalence affects incidence, can affect incidence, especially for communicable diseases. And you'll be surprised that even some of the diseases that are not communicable in the name of like infectious, they can still be communicable by behavior. And in the same way, incidence, obviously, we all know fits into prevalence. And these are the differences. I hope this is my last slide. I believe it is. Let me just highlight 1 or 2, guys. Only 2. I'm going to highlight only 2. I think I've explained many of them. You only get prevalence from cross-sectional studies. This is why in study designs, we say cross-sectional studies are prevalence studies. You can only estimate prevalence from cross-sectional studies and incidence from cohort studies. Well, we have new technologies these days we can use to estimate incidence from cross-sectional studies, okay? If you have a question, I can answer that. But traditionally, we only estimate incidence from cohorts, longitudinal studies where we follow people through. Prevalence measures morbidity. There is no mortality is not prevalence. Mortality is incidence. So incidence can measure both morbidity and mortality. You can't say, what is the prevalence of dead people in your community? It makes no sense. Mortality is incidence. And that's the last thing I say here, that mortality is incidence, is a special case of incidence. So incidence, when we talk about incidence, we're really talking about morbidity. When incidence talks about death, it becomes mortality. And there are different kinds of mortality measures, different types. I've just given a crude one here. All right. Questions, please.
Sir, the reason I raised my hand was to say that, first of all, thank you so much. I mean, my mind is blown. I know my classmates too can say the same. Yeah, we wanted to say like there's no need to hurry. We don't mind like,
Uh,
let's go as deep as we can with this. Yes, so if there are more slides, there's no absolutely no need for us to like we don't have to hurry to measures of association. If there are more things you want to talk about here, we can dwell on this and let everybody just let's enjoy it. Yes, thank you.
Lovely, lovely. Okay, let's hope we all share the same sentiment. Uh, okay. Thank you, Chidinma. Chidinma is it's doing amazing work. You can see it's her passion, first of all, that brought me here. Sir, please can you give us a lecture on this and that? All right, do you guys all share the same sentiment with her? Can I have some questions? Do we have do we have do we have questions? Who is saying more wins? More wins to who? Oluwatayo. Okay. Do we have questions, Chidima?
I haven't seen any in the chat box. Okay, there's a hand raised. Fatima's hand is raised, so I'm going to ask her to unmute. Just a minute.
Okay. And somebody says attention span. We don't have the name of that person. It's not even 2 hours yet. Are you struggling with attention span?
Fatima, I'm looking for you.
Oh, somebody says explain more on the incident rate. I would want you, Mr. HP Zebook. I would want you to please specify the aspect you want me to explain for.
Fatima, you can unmute.
Okay. Thank you very much, sir. Thank you very much, Chidima. This is an amazing session. I can say it again and again, sir. Thank you. We really appreciate this explanation. Please, I'm a bit confused with your last slide. Can you please make more clarity, please? Thank you.
Please, before you mute, just hold on.
Okay.
Uh, yeah, this
Yes.
one.
Yes, sir. You were
Yeah,
talking,
would
you were trying to relate mortality and incidence. I
yeah,
was getting it, and along the way, I'm a bit confused about
yeah.
it.
Don't mute, don't mute. I want you and I to have a conversation.
All
Eh,
right.
what do you remember between mortality and incidence? What do
Okay.
you remember?
Okay. What I remember is that you said you were talking about that we can estimate prevalence from cohort study, and incidence can be estimated. Uh, um, on this particular slide, I can't really say exactly. That is why I said I shouldn't just keep quiet. It's better I should just call your attention for
That's
my
good. That's good.
explanation.
But do not mute yourself. Do not mute yourself. I want to ask you a question. I'm taking you back. This is a study. You and I, let's assume you and I are researchers, right?
Yes, sir.
Fatima, how many people are
Yes.
in this class? How many people are in this class, Fatima?
96.
96, please write it down. 96 people, write it down.
Yeah.
Are you a nurse, doctor, or what?
I'm a biologist.
Biologist. Lovely.
Yeah.
Please, Fatima, I want you to take a questionnaire and go around all 96 people and ask them how many of them have cough. Cough. And let's assume you've done it. You don't have to do it now.
Yeah.
96. 20 of them said they had cough. 20 of them told you they have cough.
Okay.
What kind of a study is that? What kind of study design have we just implemented? We went to 96 people. We asked
Yeah.
them or tested them. Maybe we asked, maybe we tested, doesn't matter. User, you don't have to answer. I'm having a conversation, please. Uh, uh, What kind of a study design is that, Fatima?
Okay, I can say for the question that I have to go around the 96 people, it could be an association question because it has to do with
Oh, no, no.
population, and I
I
think
was saying
for the
study
design,
design. Study.
I think
Have you guys done study design?
yes,
Okay.
yes, we've done.
Okay.
I think it's
Fatima?
incident study.
No, no, it's not.
Okay, thank you.
It's not. Okay.
Okay,
That
thank you.
kind of a study is called cross-sectional study.
Okay.
Or maybe what was confusing is that you went to all 96. It doesn't
Mm-hmm.
matter, it's still cross-sectional. When we say
Okay.
cross-sectional, we say cross-sectional to mean two things. Yes, now the rest people can answer. We say cross-sectional, everyone listen. We say cross-sectional to mean two things, Fatima. Cross-section of time and cross-section of people, cross-section of the population. There are 96 people. Maybe you interview all 96 or you interview 70 of them. That's
Mm,
cross-section.
okay.
But even if you interview all 96, it's still cross-section of time at this point in time. Are you with me?
Yes, sir.
Okay, so that
Okay.
kind of a study design is cross-sectional. Now, 20 divided by 96, what's the answer? Out of the 96, 20 had cough. 20 divided by 96, what's the answer?
0.2.
Thank you. 0.2. What is that? Is that prevalence or incidence?
0.2. That's
Yes.
prevalence.
No, not the answer. The fact that we are dividing 20 divided by 96. We are dividing 20 by 96. What are we calculating? Are we calculating prevalence or are we calculating incidence? Based on
So we are
how we got
calculating
the 20
prevalence.
people. Sorry?
Prevalence, sir.
Why do you say it's prevalence? Why?
Because the 20 are part of the 96. That's the
You,
20 are
yeah,
affected
that's
population.
perfect. That's perfect. That's perfect. You have answered my question. I only wanted to make sure you understand that before we can even talk about mortality.
Yes, sir.
Prevalence is because 20 is part of the 96. You get prevalence from cross-sectional studies and you get incidence from cohort studies. If we get out of the 96, if 20 of them already have cough, we remove the 20, we now have 76. We then follow them through to see how many we develop cough. Any new cough case is an incident case. So incidence and follow-up go together.
Mm.
Incidence and cohort go together. Are you with me?
Yes, sir.
Thank you. So we can estimate the prevalence of cough, and we can also estimate the incidence of cough.
Mm.
Can we estimate the prevalence of death? Is it possible in a community? The prevalence of death. How many people are dead in this community? Can you find out?
Yes, sir.
No, you cannot.
Okay.
Can you go to a community of 96 people, and say to them, which of you is dead? Are you dead or
No,
alive?
no, no.
Can
It's
you do
not
that?
possible. No,
It's
sir.
not
It's not
possible.
possible. It's not
Are you with
possible.
me? Yeah. But if you follow up the 96 people, can you estimate the incidence of death?
Yes, sir.
Thank you. So death or mortality is incidence, it's not prevalence.
Yes, sir.
That's all I have said. I said mortality is incidence, is a special kind of incidence. And there are different kinds of measures of occurrence or measures of frequency we use for mortality. And then I gave you one, I didn't explain any of them because of time, and that's not why I'm here. I gave you one, which is a crude mortality rate.
Mm.
Okay, you can go back and read it.
Okay, sir. Thank you so much, sir.
You're welcome. Thank you. And sorry for keeping you on the microphone, but I
Thank
hope
you
you
so
learned
much.
something.
Appreciate. Yeah,
Lovely,
I love a lot.
lovely, lovely. The total population size and the total number of deaths, that's crude. Okay. Instead of just looking at total number of deaths, can we look at the cause specific? The total number of deaths due to HIV. Can we get that? Cause specific mortality. Oh, yes, we can. Total number of deaths due to cardiovascular events, due to stroke. Can we get that? Yes, we can. Due to something else, can we get that? Yes, we can. All right, if we can get a cause-specific mortality rate, can we also get for different age groups? Because we don't want people to be dying before a particular age. Let's estimate the mortality rate for each age group. We can get that. Yeah. Oh, there's something called case fatality in infectious diseases. Again, you see why I didn't go into that? Because not everybody is, we have to go through mortality rate before we even go into case fatality. It's very similar to mortality rates, except that it's cases. Instead of the population now being your denominator, it's the total number of cases that your denominator. All right, this is not part of the scope. If you didn't understand this, no problem. But you must understand that mortality is incidence. That's the main message here. I think we should take a break for 5 minutes. I don't know what you think, Chidima. Do other people still have the petrol in their tank to go into the next lecture? Or should I just send the slides?
We have one more hand raised, just one more hand raised. I don't know if he still wants to ask his question. Then after that, I think we can take a break and we will be back.
Okay. Okay.
Okazie Friday, please, you can ask your question. You can unmute. Yeah.
Yeah, thank you very much, Ma and Dr. Bello. Sincere appreciation to the impact you are making.
Thank you.
I got a bit distracted. Someone ran into my room and I was cut off as the flow went on. At the point when you transited from prevalence to incidence, where you gave the example with the common code and all that, for me, that was the epicenter of this section. But I think I was cut off totally, and it pained me that I missed that particular aspect. If you don't mind, just a little recap when you transited from prevalence to incidence. Thank you.
All right, don't switch on your mic. Don't switch off your mic. Don't switch off your mic. Because you've asked nicely, I'll have a quick recap. uh, I want to explain the things you don't understand, not to repeat the part that you were distracted. But as a gentleman, you've asked nicely. I will have a recap. But let's have this conversation. What's your name, please?
Okezie is the name.
Sorry?
Okezie.
Okay, Zie. All right. Okay, Zie. Let's not use the example I had earlier. Let's use the example that Fatima used. Okay, Zie, do you remember the example Fatima used? How many people were in this population? Fatima's population?
96.
Lovely. And we went round. It took us three
Can you hear?
weeks. It took us 3 weeks. We're checking which of them have cough, and we found that 20 have cough. That's kind of a study. It's called cross-sectional, and that kind of a measure. Okay, let me not go ahead of myself. That's a cross-sectional study. What percentage of the people have cough? Okay, Zia?
Okay. Yes.
Let's do it together.
That's 2%.
No,
No,
you can use your
no,
calculator, no problem.
so, 0.2.
Give it to me in percentage. He already gave it to me as she already gave it to me as a proportion. Give it to me in percentage.
Okay. 20.8%. If you like
Thank you.
21%.
21%. It's always good to report it with one decimal place when you write scientific papers or research reports. One decimal place. 20.8%. 20.8%. What is that, okay? Is that prevalence or incidence? We've just estimated.
Incidence.
Okay, I think that's where you lost me there. Okay, Zia, that is called prevalence.
Okay.
Don't look at the title of the slide. Prevalence, prevailing, already existing. Prevalence is already existing. They were already having the cough when we got there. We didn't wait for them to develop the cough. We only asked them if they have cough. That is prevalence. The prevalence of cough in this study population is 20.8%. Are we on the same page? Your microphone should be on, please. Have I lost you?
Hello, sir. I can hear you. Sorry, I can hear you.
Please keep your microphone on. We're doing this together.
Okay.
Is it correct to say the prevalence of cough in this population is 20.8%?
Yes.
Lovely. If you want to estimate incidence, okay, Zé, incidence means new cases. These 20 people, they're not new cases. Do you agree with me?
Yes.
They are not new cases. So incidence, when you define incidence, you have to think of new cases. And the moment you think of new cases, you have to think of period of time because you don't walk into new cases. You wait for new cases. You don't walk in and shake their hands. If you walk in and shake their hands, they are not new cases. They are prevalent cases. If you want incident cases, you have to wait for them. So for us to get incident cases, we have to start with 76 people. Do you know where I get that 76 from? If you will not do your part,
So I
I will
think we
stop.
can go.
Oh,
I think we can
Can
go
I
on
stop?
break. I don't think he's present here.
Yeah, it's not. All right, thank
hello.
you.
Yes.
After 5 minutes, we'll come back and continue.
All right. Thank you very much, sir.
Okay, right.
Hello, sir. Hello.
Hello. Oh, did you call
Yeah,
me
we're
already?
ready. We're ready when you are. We're
Okay, I
ready
didn't
when you are.
realize. My
Okay,
apologies.
no problem.
Okay. Okay, so let's do this. I have my note here. Where is it? Okay, so let's take measures of association, which we also call measures of effect. Okay, can we go, Chidima? We ready to go?
Yes, yes, we can fly.
Lovely, let's go. I said something to everyone earlier that if you are studying, if your research question is on, I'm looking for something here, just a second. If you are doing a study on the association between two variables, then you will have to pass through, you have to pass through, just a second, please. Yeah, so let's look at one or two examples earlier. Is there an association between alcoholism and erectile dysfunction? And that is coming from an iPhone user. I wish I could. Is that right on my whiteboard? What's that? Okay. Okay. So, is there an association between alcoholism and erectile dysfunction? So, I would imagine, let's resist the temptation to write on the whiteboard. Eunice, okay, let me just stop the whiteboard then. Should I stop the whiteboard?
I want to check the control so I see how I can just stop every other person. Yeah,
Yeah, but this is a university. We don't need to stop people. People should not write on the
please
whiteboard.
let's get our hands out of the screen, please, please. I already disabled it here. I don't know why it's
Okay, that's good. That's good. And that's not me. That's another Zoom user. Okay, so erectile dysfunction. The person. I wish I knew the person's name. Uh, I wish I knew the person's name. Correlation between. Uh, okay, so let's take from Aphilemon, relationship between sickle cell disease and delayed wound healing. So Aphilemon is interested in measuring delayed wound healing. So she would have something like, let's say we have, oh no, okay, I'm gonna stop. I'll do it on my slide. I think people are fascinated by the whiteboard. All right. So let's assume that I wanted to use a whiteboard because this place is not clear enough. Okay, I'll continue. If you measured, for you to talk about measures of association, you should have first, you should first have a measure of frequency. So a Philemon is wanting to study association between delayed wound healing and sickle cell anemia. So Philemon has a way to measure delayed wound healing. Let's assume a particular wound should heal after 7 days. And then after the 7 days, there are still some people whose wounds did not heal. So Philemon will start with, let's assume she starts with 100 people. 100 people. All of them have wounds. All 100 people should definitely have wounds. And then out of the 100 people, we find that 70 of them have normal healing, and we find also that 30 of them have delayed healing. Now, of this 30% could be incidence or prevalence, depends on how you measure it, but let's assume that it's incidence. And he said 30% of them have delayed healing, and she now wants that 30% is a frequency of, is a measure of frequency. It's a measure of frequency. But she doesn't want to stop there. She wants to determine a measure of association. Why? How do I know that? Because she thinks that sickle cell anemia has something to do with delayed healing. Therefore, she will say to herself, 30% of all 100 people have delayed healing, but I hypothesize that sickle cell anemia has something to do with delayed healing. How about I get two groups of people? One group is 100 people with wounds, and another group is another 100 people with wounds. There are different kinds of study designs, different types, okay? And she says, these people, of course, the whole 200 of them have, okay, maybe to make it easier, let's split it 50-50, it doesn't matter. These 100 people have wounds, and these 100 people have wounds, and these guys do not have sickle cell anemia, okay? So we'll say no sickle cell anemia or sickle cell disease. And here we'll say these guys have sickle cell disease. Okay. And then she says, out of this 100 without sickle cell and 100 with sickle cell, all of them have wounds. What percentage have delayed wound healing? Those with no sickle cell, we find 70% had delayed wound healing. And those with sickle cell anemia, 44% had delayed wound healing. And Philemon says, I said it. I knew that sickle cell anemia delays wound healing. Because among those without sickle cell anemia, 17% have delayed wound healing. Among those with sickle cell anemia, 44% have delayed wound healing. And then Philemon's lecturer or supervisor says, you have done very well. You have given me two measures of frequency. Two measures. Or, no, that's not correct. You've given me a measure of frequency in two groups. Well, it's two measures of frequency in two groups, 17% and 44%. Will you give me the result in one answer, one statistic? I don't want to go home with two statistics. I don't want to go. No, that's not a case. It's not a case. It's not a case study. I was asking the question. That's a study design question, but it's not a case study design. Okay. I just want to focus on the statistics, right? Lovely. Okay. So the supervisor says, I don't want to go home with two statistics. I want to go home with one statistic. Can you give me a measure of association? You are now saying, or you are now thinking that there is an association between, you are now thinking that there is an association between having delayed wound and having sickle cell anemia. That's what you're trying to tell me, isn't it? Yes, sir. That's what I'm trying to say. 17%, 44%. Okay, if you think there's an association, no problem. We can prove it statistically. But what measure of association do you want to use? All of this explanation I have done is not just on this slide, it's to set the foundation for the next few slides. And that is the first paragraph there, the first bullet there. If you have measured the frequency of a disease in two different groups, exposed and unexposed, men and women, sickle cell, no sickle cell, you've measured the frequency. We've already covered frequency. Maybe you measured prevalence or incidence, it doesn't matter. You measured it in two groups. How would you tell which group is worse off? Well, I can tell by just looking at it. 17% is less than 44%, fair and good. But statistically, you could have a measure. Would you subtract 14 from 44, 17 from 44? Or would you take a ratio? That is what we call the measures of association. The measures of association are either ratio measures or they are difference measures. We also call it the measures of effect. Now, the same example is back here. This time, not a Philemon, because emphasis is good for everyone. The person who didn't get it with a Philemon's example can get it with this one. This is part of the work I did for my PhD. A researcher found that the frequency of pregnancy loss is different between women who drink alcohol and those who do not drink alcohol. She found, or he found, that 40% of women who drink alcohol during pregnancy had a pregnancy loss. This pregnancy loss will be miscarriage or stillbirth, doesn't matter. They lost their pregnancy. But those who did not drink alcohol, 20% had pregnancy loss. Does alcohol have an effect on pregnancy? Even my grandmother, who didn't go to school, will say yes. But the next question is, how would you report that effect? Would you say, oh, 20% higher? Because 40 minus 20 is equal to 20. Or would you say 2 times higher? In other words, would you take a ratio or would you take a difference to capture this effect? Once knowledge of science begins, when they can capture what they are explaining or what they are talking about in numbers. So effect is a number. Effect is a number. Association is a number in public health research. We can use a ratio or we can use a difference. If Chidinma went to Harvard University, both of Chidinma and I went to the same medical school, we're in the same class. When we graduated, we were both earning 10,000 naira, same salary. And Chidinma went to Harvard. She's now earning 100,000. And I went to let's say another university, and let's call it, let's just say Stanford, and I'm now earning 50,000. Harvard had an effect on Chidima's salary. So Chidima is earning, let's say I'm earning 40,000. Chidima is earning 100,000 and I'm earning 40. Do you say, oh, Chidima earns 2.5 times more than Braimoh? Or do you say Chidima earns 60,000 naira more than Braimoh? Both of them are correct. Difference, ratio. I'm here to tell you the different measures of effect. And all measures of effect fall into two categories. One is a ratio, and the other is a difference. Let's proceed. Oh, I have used. So that's what I've just talked about, ratio and difference measure. I think I'm going to be spending time on the ratio. I think I've already explained it, like I said to you. I've laid the foundation. The ratio, when we talk about ratio measure, it's really simple. It is the ratio of the frequency in both groups. Everybody, the ratio, even if you didn't do mathematics, I know you know ratio means to divide. To ratio is to divide. So you take the frequency in one group and you divide it by the frequency in the other group. And epidemiologically, we say we are comparing two groups, exposed and unexposed. So there are different kinds of ratio measures. That is why you will hear odds ratio, risk ratio, hazard ratio, fecundability ratio, and all of these ratios. They all mean the same thing. It just depends on what you're ratioing. If you're ratioing two salaries, it will be salary ratio. If you're ratioing the height, two heights, one person is 2 meters tall, the other one is 1.5 meters, 2 divided by 1.5, that's height ratio. If you are ratioing the odds of disease, that's odds ratio. If you are ratioing the prevalence of disease, that's prevalence ratio. If you are ratioing the incidence of disease, that's incidence ratio. That is why you must first understand prevalence and incidence, measures of frequency, before you come to measures of association. Because measures of association is the ratioing of the measures of frequency. The philosophy is the same. The numerator is always the exposed. If I ask you to ratio these two things, you say 40 divided by 20. You don't say 20 divided by 40. Why? Because this woman who is drinking is the exposed. She's exposed to alcohol, which is making this group, not the woman. The group is a group thing. It's a group thing. It's not a personal thing. It's making them more likely to have pregnancy loss. So I'm starting with risk ratio. Risk ratio is a ratio of the risk of disease between two groups. Full stop. Okay, which group goes on top? The exposed. Which groups go below? Unexposed. Numerator, exposed. Denominator, unexposed. I see people cramming risk ratio, especially odds ratio. Lots of people cram it. So no, don't cram it. Think through it. Think through it. Is a ratio of two measures of frequency. Which measure of frequency are we talking about here? Risk. Which risk? Incidence. Incidence is risk. If it's a prevalence ratio, we will call it prevalence ratio, because incidence is not, a prevalence is not a true risk though, even though we say it's the risk of already having the disease. It's not a true risk. So we usually wouldn't call prevalence risk or rate. Many people, even very prestigious newspapers, will say prevalence rate. There is no epidemiologist that's gone to a good epidemiology, a good school of public health, that will call prevalence rate. Prevalence is not a rate and will never be a rate. So we say prevalence ratio. Don't say the prevalence rate was 15%. Just say the prevalence was 15%. Because it's not a rate. I showed you how to calculate rate, and I showed you how to calculate prevalence. I digress. So risk ratio, also called relative risk, is the risk of disease in exposed divided by the risk of disease in unexposed. If you want to write it out with your own pen, just say the incidence of disease in exposed divided by the incidence of disease in unexposed. If it is rate ratio, you say the rate of disease in exposed divided by the rate of disease in unexposed. If it is prevalence ratio, the prevalence of disease in the exposed and the prevalence of disease in the unexposed. I think this concept of exposed and unexposed may need me to digress for 5 minutes and explain it. Ladies and gentlemen, the null hypothesis would have you think and believe that things in life are random. The null hypothesis would have you believe that things in life are random. So if you have drinkers, women who drink during their pregnancy, and non-drinkers, women who do not drink or did not drink, because it's a study, let's use did not, a particular study, past tense. Women who drank alcohol during their pregnancy, there were, let's assume, 74 of them. I'm going to do this again when I get to the next slide. I'm just making up my own numbers. I don't remember the numbers I have on the other slide. Non-drinkers, let's assume 80. They don't have to be exactly the same number. When people are young and they are studying this, do we have to have exactly the same number of drinkers and non-drinkers? It's good to have close numbers. It doesn't have to be exact. Statistical efficiency is better if they're more or less equal, but there are some study designs, it's even 2 to 1 or 4 to 1. Anyway, I believe as a researcher, first of all, what are we looking at here, guys? We're looking at 2 variables here. Look at this. We're looking at 2 variables, only 2 variables. People get confused. I want to do this. Spontaneous abortion. No, let's just say pregnancy loss. Pregnancy loss. So you either have pregnancy loss equal to yes, or you have pregnancy loss equal to no. If somebody looks at these things, he thinks we're talking about 4 variables. No, we're talking about 2 variables only. Only 2. The one variable we're talking about here on the left-hand side is called drinking. The variable is called drinking. You either drink or you don't drink. It's a variable, 1. 2 groups, 1 variable. Height is a variable. You're either tall or you're short. Tall is not a variable. Short is not a variable. Height is the variable. Drinking is the variable. Pregnancy loss is the variable here. Pregnancy loss is the variable on the right-hand side. So I'm looking for an association between one variable and another variable, drinking and pregnancy loss. These are just groups based on whether you drink or you have pregnancy loss. Does going to Harvard improve your salary? The university you go is one variable. The salary you earn is another variable. Does the type of university affect the salary you earn? Those are 2 variables. Whether you went to Harvard or UNIBEN or UI, those are categories of university. They are not variables. Those are groups, they're categories. Anyway, I'm trying to digress for those who are not health people, but let's come back. Drinking One variable, two groups. Pregnancy loss, one variable, two groups. As a medical doctor who has been seeing, I'm not a doctor, I'm a scientist, but it's just a conditional statement. As a medical doctor who has been seeing patients, I have started to hypothesize that drinking has something to do with pregnancy loss based on some intelligence and observation. The null hypothesis says, no, it's never been done before, don't worry. There's no association between drinking and pregnancy loss. The null hypothesis is the hypothesis of laziness, is the hypothesis of no effect, is the hypothesis of no association, is the hypothesis of don't waste your time, don't try, you won't find anything. But the alternative hypothesis is the hypothesis of effort, is the hypothesis of systematic findings, systematic observation. So no, I think the null hypothesis is not correct. The null hypothesis is also called the hypothesis of randomness. What is randomness? And this is one of the things that has held us back on the continent. Martha, what are you drawing on my screen? You know, I would like to see where people take these lectures from. Yeah. Anyway, the null hypothesis is the hypothesis of randomness. And that's one of the things that has held Africa back. Because Africa, we think a lot of things in life are random. When we were growing up, our parents would say, no be that school your brother go. Why you want to go private school now? I don't get money to send you go private school. Now that school your brother go, your brother graduate. In other words, what your parents are saying is that your academic performance has nothing to do with the school you go, and that's rubbish. Oh, God go bless, God go bless, God go bless. It not be how many hours you study. The race is not to the swift, of course. I don't want to go into religion. We say things like that. And those kinds of statements are null hypothesis statements. They are statements of randomness, that whether you will succeed tomorrow is random. It has nothing to do with how you spend money, how you save, how you study, the kinds of friends you move with. That's the null hypothesis. I digress. The null hypothesis says pregnancy loss in women is random. It has nothing to do with what they do, what they drink, what they smoke, where they live. It's just random. There's a demon or an angel of randomness spreading pregnancy loss. And then this doctor says, no, I don't think so. I think pregnancy loss has something to do with drinking. And then he follows them through. 74 of you women, you say you drink? Yeah, all right. Let me follow you through. It could be cohort, it could be cross-sectional, we could use different study designs. I'm not focusing on study designs. And the person follows them through, and he finds out that 40 of them had pregnancy loss. We are not interested in who did not have pregnancy loss. No, we are not interested in that. When we do research, we are not interested in those who don't have the disease. We're interested in the disease. And among those who did not drink, 10 of them had pregnancy loss. 10 of them had pregnancy loss. Okay? Among those who did not drink, 10 of them had pregnancy loss. Now, this is what you have to understand, guys. Maybe I should go back. I have one variable here called drinking, and I have another variable here called pregnancy loss. In biostatistics, this variable is called independent variable, while this variable is called dependent variable, because we are hypothesizing that pregnancy loss is dependent on drinking. In biostatistics, we say independent and dependent. In epidemiology, we say exposure and outcome. Exposure is drinking. So some people are exposed to drinking, some are not. The exposure under study is drinking. And the outcome we are waiting for is pregnancy loss. We are not saying, this is what I was saying to you earlier when I started. We are not saying that everyone who drinks will have a pregnancy loss. That is the argument of the layman in the street. It's not a scientific argument. Oh, but I know someone who didn't go to school and is not a rich person. That's not what we are saying. We are saying the probability of having pregnancy loss is higher if you drink. That is our hypothesis. And so we found that 40 people had pregnancy loss. And here we found that 10 people had pregnancy loss. Had pregnancy loss. Both of them are pregnancy loss. But on the left-hand side, both of them are not drinkers. One drinks, the other doesn't drink. In both groups, we are measuring the same thing. You don't measure pregnancy here and come here and measure no pregnancy. No. Maybe I hope you don't get confused by this no pregnancy I have here. I think I should cover it. Okay. Just a second. Okay, so pregnancy loss is 40 here and 10 here. I want you guys to give me in the chat. Listen so you can get it in the chat box. What percentage of drinkers had pregnancy loss? Put it in the chat box. Percentage. Or maybe proportion, that's okay. What percentage of drinkers had pregnancy loss? Joel, 54.1%. Lawrence, 54%. Fatima, 54%. 54.1%. Bethel, everybody got the answer. Thank you. You can stop. Let me not say everybody. Everybody who submitted got the answer. 54%. Can you do the same for the other group? What percentage of non-drinkers had pregnancy loss? What percentage of non-drinkers had, yes, Salome, that's correct. What percentage of let's move over to non-drinkers. What percentage of non-drinkers had pregnancy loss? Yep, 12 points. Thank you, everybody. Lovely. Okay, since we already have the answer in the same unit, we can as well just continue. The risk of disease, ladies and gentlemen, if you put your eyes among who are the exposed, okay, because of time, if it was face-to-face, I would be asking you. The exposed are the drinkers, and the non-exposed are the non-drinkers. So therefore, we are putting drinkers on top. In fact, if you're writing an exam, I hope you will write the risk of disease in drinkers. In fact, you don't say disease. You can start with this. You go under the incidence of pregnancy loss in drinkers divided by the incidence of pregnancy loss in non-drinkers. You have given me the incidence of pregnancy loss in drinkers, and you said to me it was 54.1%. Okay, or 0.541. It's okay. Let's keep it simple. Or maybe it's simpler to remove the percentage. It doesn't matter. You know. So we have that. Okay, divided by 12.5%. The percentage will cancel out, so it doesn't matter. Whether we say 0.54, 0.125, doesn't matter. Ladies and gentlemen, give me in the chat box the risk ratio. Oh, people are already giving it to me. Amazing stuff. I think it's 4.3 according to the two answers I got. 4.3. Amazing stuff. All right, you saw where I was going. You guys saw where it's going. I want to see new names. I want to make sure it's not only this Afilemo and Joel and Salome that are answering the same. Can I get new names? Did you get 4.3? Favor, yes. Favor 4.3. New names. Fatima, I've seen your name before. Lawrence, I've seen your name before. Can I get new names? Blessing, okay. Okay. Allah, that's a Yoruba name. I almost got it. Joel, beautiful. We are all on the same page. Then I will be done in the next 30 minutes because you guys are flying. Or 20 minutes even. Lovely. Enough. Enough. You're flying. You're flying. It's good. It's good. It's good. Okay, let's continue. Enough. Let me clear my board. I have explained this logically. Let's go mathematical. It's here. This is called a 2 by 2 table. I want to think all of you have seen a 2 by 2 table before, a contingency table. Okay? The 2 by 2 table, I wish I had used these numbers on this page, but it's okay. It's a different set of data. It buttresses the points. All of those numbers we had there, we want to put them here now. Or maybe I should put my numbers here. No, no, no. You guys went through that calculation. You went through the calculation. Let's put the numbers here because you went through the calculation. This other one here, I'll send you the handout. You can use it in your own time because you went through the calculation. Let's do our own here. Let's enjoy the benefit of your hard work. Is this okay? Just pardon me. What goes into the roles? Exposure or outcome? It really doesn't matter, but I prefer to put the exposure here. Drinkers or drinking goes. What's that? What's a question for this answer? What is that? That's not a question to ask, legend. That's not a question to ask. You ask, there's some questions you ask your colleague after the class. You can ask what's the question for this answer. It's like the other guy that was asking me a question. He said he was interrupted and he still was interrupted when I was talking. I was teaching some PhD students the other day at Wits University, and one or two of them were making noise in class, and you can tell they're from West Africa. It's a program that attracts participants from all over the continent. And the noisemakers are from my country, which is unfortunate. I said to them, you can't, and one of them asked a question like that. I forgot him. No, I think they were making noise. I forgot what it was. If you get to a lecture hall at Harvard University, you can understand, you will see why there is a first ward and there's a third ward. Everywhere is quiet. Everybody is quiet. Everyone knows when to engage. So I don't understand what is the question for this answer. I've never heard of that in my life. All right, guys, drinking. We have, let's put exposure in the rows. We have drinkers and we have non-drinkers. And then we have the outcome in the columns, spontaneous abortion. No, sorry, pregnancy loss. Remember, this is my topic, so I keep using some other terminologies. Pregnancy loss, no pregnancy loss, no pregnancy loss. No, I think I should just say yes and no. I should just say yes and no. Pregnancy loss, yes. Pregnancy loss, no. And then I put on top there, pregnancy loss. Pregnancy loss. Pregnancy loss, lovely. Ladies and gentlemen, I want you to tell me what should go into these different things. A, B, based on what we did earlier, the data I gave to you earlier. C, D. Mathematically, I would say A plus B here, but I want to make it easy for you. I just say E. Instead of saying C plus D, I will put F. And here, I will put G. So what we described in English, we want to put it in a table. And this kind of table is called a contingency table. Epidemiologists would call it 2 by 2 table or R by C. Letter R, row by columns. There are two rows here. There are two rows here. Why are there two rows? Because we have drinkers and non-drinkers. Row number one, row number two. This one is not a row, it's just summation. Two rows, two columns, yes and no. So it's an R by C table, R by C table. The number of rows is two, and the number of columns is two. So we call it a 2 by 2 table. Did I digress again? Ladies and gentlemen, how many drinkers did we have in that example? I think I've even forgotten some of the numbers, but I think Salome put her formula here. Give me the answer in the chat box, everybody. How many people altogether were drinkers? I'm looking for E. 74. 74. All of you would agree that 70 E is equal to 74. Thank you, everybody. E is equal to 74. We don't care whether you had... Maybe I'm over-explaining what you guys already know. Okay. Who gave me all the answers now? Philemon. Okay. Maybe Philemon is saying, no, we know this. So how many non-drinkers did we have, everyone? 80. Thank you. 80. That's how I like to start. I want to start with the denominator. I don't like to cram. I hated cramming from Uniben. I want to understand. I want to explain. I don't want to say A, B, C, D plus. No, no, no. 74 drinkers, 80 non-drinkers. All right. Let's focus on the drinkers. The drinkers are the exposed. The drinkers are the exposed. Out of the 74, give me A, everybody. A, 40. Everybody got it? No, I did. The first two people got it. A, if you look at A, for those who don't get it, I don't think you brought me here to sound intelligent. You brought me here to simplify things for you. Thank you. Who's that person? Natty, Mr. Natty. Thank you. That's why you brought me here. For those who are struggling, A is out of these 70 drinkers, we're looking for how many of them had spontaneous abortion? 40. And by subtraction, we know that 34 did not. Nobody needs to give us 34. We are not interested in the 34. We are interested in the positives. So, but by subtraction, we know it's 34. And who can give me C? I've actually forgotten what the number is. I think it was 10, yeah. 10. Not 20, Zoom user. Not 20, 10. Lovely. 10. And by extension, subtraction, that will be 70. So when I can add up this here and get 50. The total number of pregnancy loss in the whole study, if we're not looking at drinkers and if we didn't care who drank and who didn't drink, it's 50. And the total here is 104. And the grand total is 154. If you have been able to plug in these numbers the way I have been, you would not have a problem with risk ratio, odds ratio, or whatever. So the risk of disease in the exposed is disease divided by denominator. We already got the answer. We're not going to repeat it, but I will just type it here. I'll say 40 divided by 74. And then I'm going to have another risk of exposed, risk of pregnancy loss amongst the unexposed. Unexposed are non-drinkers. 10 divided by 80. So I now have 2 divided by, and you can do a simple arithmetic and you get your answer. All right, you can take a picture of this and then move to the next slide. But I think you already all understand it, so let's continue. So that's what is here, guys. I don't have to explain this. You know what I've explained so far? Risk. I want to take 10 minutes to explain odds ratio, and then I will be wrapping up, Chidinma. I'll send the notes. I'll really have to stop after 10 minutes. Maximum 14. Okay. This is where people have problems. I've already explained risk ratio. You just look at why you shouldn't cram. Look at why you shouldn't cram. Guys, put in the chat box the total number of people who are exposed according to this table. Put in the chat box total number of people who are exposed according to this table. Thank you. No, not 47. Not Salome. You have picked the top one because that's the table we just used. Thank you. Thank you. It's 23. And according to this table, tell me the number of people among those who are exposed, how many had pregnancy loss? How many had pregnancy loss? 3. Thank you. Don't cram. Go think through it. So 3 divided by 23 is what you're looking for. That's the risk. That's incidence or prevalence. I told you incidence and prevalence have the same formula. So whether you're calculating incidence ratio or prevalence ratio, you will still have achieved the 4.3 you got. You only need to know how the data was collected in order to know whether it's prevalence or incidence. But here is where the issue is. What is odds ratio? You know why odds ratio is difficult for people? Because when you tell them about incidence ratio or risk ratio, at least you already told them about incidence as a measure of frequency. When you say prevalence ratio, at least you already told them about prevalence as a measure of frequency. But we didn't have odds as a measure of frequency. Why are we now talking about odds ratio? I really wish I could take this as a different lecture another day, but there will be no other day. It's just a guest lecture I'm giving to you guys. But a day with me, what is 7.6? Okay, don't worry, because I think you're muted. So what is odds ratio? Odds ratio is the ratio of the odds of disease in exposed divided by the odds of disease in unexposed. The problem now is that I don't know what odds is. Somebody might say, I've never heard of odds before. It's okay. Let's go into odds. Ladies and gentlemen, odds and probabilities are brothers. They are brothers. That's the first thing you have to take home. If you can calculate probability, you can calculate odds. In English, no, in statistics. In statistics, the odds of an event is the probability of that event happening divided by the probability of the event not happening. Take that sentence, put it out in a formula, and you see. The probability of an event happening divided by the probability of the event not happening. But I don't like that. That's what you give to it. You should get that formula, that definition I just gave. Get it for your exams. That's what you give right in your exams. But this is what you use in everyday life. The definition This is what you use in everyday life. The number of events divided by the number of non-events. So let's go. Everybody, let's go. I think I'll end here, guys. I'm getting tired. uh, let's go, guys. I'm going to go row by row. I'm going to go row by, maybe I should do the first 3 rows first. Ladies and gentlemen, I have 1 white ball and 1 black ball. What is the probability of picking a black ball? Chat box. I have a basket with 1 white ball and 1 black ball. What is the probability of picking a black ball? The first 3 people have said 1, and the rest are saying 1/2. And I agree with them. Ladies and gentlemen, if you wrote 1, please remember, probability is what you are seeking for divided by everything in the basket. You are seeking for black balls. How many black balls are there? 1. How many balls are there altogether? 2. That's the probability of getting a black ball. Scenario number 2. What is the probability of getting a black ball in this scenario? Everybody, chat box. 2 white balls, 1 black ball. 1/3. Thank you. Ladies and gentlemen, the third scenario, before I go to odds, I'll do this and then go to odds. 4 white balls, 1 black ball. What is the probability of picking a black ball? I don't think it's 1/4. Somebody says 0.25. I think favor keeps rescuing us. 1/5. The total number. 1/5. Are they with me? Is not 1/4. It's 1/5. The total number. 4 white balls and 1 black ball. Yes. 1/5. Lovely. So probability, I'll write it here, is events divided by all. That's probability. But odds, on the other hand, is events divided by no event. Aha. So let's get the odds. I'll do the first 2 and you do the rest. What's the odds of picking a black ball here? I'm seeking for a black ball, and so it's 1 divided by non-black balls. I'm not going for the total in the denominator. I'm going for the non-events. So it's 1 divided by 1. Thank you. 1, I have to write it here so that people can see it. 1 divided by 1. Thank you. And scenario number 2, thank you, Fatima, that's correct. The odds of picking a black ball in scenario number 2 is 1 black ball divided by non-black balls, which is 2 white balls. Thank you. And here, 1 divided by 4. Everybody got it now, so we can go faster. I'm doing all of this to drive home a point. So this is 2 divided by 10. And no, I'm wrong. That's 2 divided by 12 equal to 2 divided by 12. Here, 2 divided by 10. Here, 10 divided by 100. Here, 10 divided by 90. Here, 0 divided by 100. Here, 0 divided by 100 as well. Here, here, 10. I want to get the answer for the last row. Ladies and gentlemen, the last row. 0 white balls, 10 black balls. What should I put under probability? Chat box. No, don't give me the answer. Give me the fraction. If you run to the answer, you would fail. No, give me the fraction. You have to get the formula before you get the answer. The last row, all of you are saying 10 over 10. Oh, that's correct. Oh, I'm wrong. Sorry. Oh, no, 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 I'm wrong. Okay. Because you're not giving me the answer, maybe that's why I was not getting it. 10 divided by 10. Odds, please, for the last row. That's what I'm waiting for. 10 divided by 0. Thank you. We stop there. We stop there. Please take a picture of this one. You get the notes. You can do it again in your group, discussion group. One conclusion. Let me see if I have it on my next slide. Let me see if I have it on my next slide. One conclusion, I'll just give it to you here. You can see it here, is that odds is always higher than probability. Odds is always higher than probability, unless there's no event. Unless there's no event. Odds ratio is always higher than risk ratio or relative risk. 0.5, 1. 0.33, 0.5. 0.2, 0.25. What do you notice? Let's see the chat box. Some people are typing. Nice. Odds is always higher than risk. Conclusion number 1. Conclusion number 2. When event becomes rare, odds and probability become approximately equal. For example, 10 over 100, 0.1, or 10%, let's just say 0.1. 10 over 90, 0.11. 0 over 100, 0. 0 over 100, 0. In epidemiology, we call this the rare disease assumption. When a disease is rare, odds ratio will approximate risk ratio. When a disease is rare, odds and risk become equal, approximately equal. Why? Because 1 divided by 1,000 is essentially the same as 1 divided by 999. That 1 no longer makes a difference. When the event is rare, it doesn't matter whether your denominator is 1,000 or 999. I clear my screen and I wrap up in 2 minutes. Chinima, wherever I stop, that's where I will stop. Yeah, so you have these answers there, and there's one that's infinity. Figure that out. And so now that you know what odds are, then you should know what odds ratios are. An odds ratio is the odds of disease in exposed divided by odds of disease in unexposed. So earlier we said the risk of disease is 3 over 20, 3 over 23, and among the exposed, among the unexposed, we said 3 over 47. But if we're looking for odds ratio, we have to say what is the odds of disease in the exposed. That will be 3 divided by 20. It will no longer be 3 over 23. And the unexposed will no longer be 3 over 47. It will be 3 over 44. Are you with me? So it will be 3 over 20 divided by, where is it? Divided by 3 over 44, which will be equal to 3 3 over 20. There's no pen. You substitute. It becomes 3 times 44. Becomes 3 times 44. Okay, that's where you get your cross product ratio from. Okay. So please do this. That's odds ratio. I got to dash. Yep. And then there's the difference ratio, difference measures. So I focused on the ratio measures. I've talked about risk ratios, which is the same thing as relative risk. And I have also talked about uh, odds ratio, but I will not have time to go into the difference measures. But it's really simple. It's attributable risk. You can understand this easily. It's A minus B. Instead of A divided by B, we'll do A minus B. I will stop there for now, and I hope you gain something.
Wow, thank you. Guys, please let's use our emojis. I know we are muted, but please let's use our emojis. This is I don't know. This is too awesome. This is too awesome. I'm way too excited. I'm way too excited. Yeah, we're discussing in the group that we're going to find a way to get him to teach us. Thank you so much, Dr. Bello. Thank you so much. We are grateful. Thank you for giving so graciously of your time. Thank you. Thank you so much. Thank you, sir. We know that
You're
you have
welcome.
to
It's
run.
been my pleasure. It's been my pleasure. It's been my
Thank
pleasure.
you. Thank you.
You're welcome. You're welcome.
Thank
All the
you.
best with your studies and all the best with your career.
Thank you, sir. All right. Good night.
Okay. Good night.
Yeah, good night. All right, guys. Thank you so much for being here. I mean, I know we are very excited. Now we have to take it to the group because I would have to end the meeting. Good night, everybody. Good night, everybody. Good night. See us in the group.